first thing, here I am. I'm Austin Parker. I'm an open source engineer at LightStep and a maintainer on the OpenTracing project. I have a Twitter account. I have a blog, like we all do. First off, I do want to have some quick notes on OpenTracing. So we recently relaunched our site, and part of that was we've added a lot of some guides and how-tos on how to start using OpenTracing if you haven't before. And even if you have before, we've tried to really expand, or we're trying to expand the amount of in-depth information to give you more information and insight in sort of how all this works. One thing we are looking for is if you are sort of, let's say a language expert, or you already have experience in OpenTracing and you're interested in contributing back to the community, we're really super excited to get more community guides written about, your favorite language or your favorite tech stack. If you really like Envoy and you want to do, hey, here's how OpenTracing and Envoy works, or Istio or C++, pick your poison. The other big thing that we've recently launched is a OpenTracing registry. So this is a searchable index of tracers, instrumentation plugins. So, hey, drop this into Spring and your stuff is all traced. It's really cool. So you can go to opentracing.io/registry to check that out. If you personally maintain any sort of OpenTracing project, even if it's not in the OpenTracing contribution organization, we'd love to have that as part of it. All you have to do is make a pull request onto the OpenTracing website repo. There's instructions on the page. If you have any other questions about it, find me after this. So let's move forward to the bigger part of this talk. So I called it, what was it? Science and Praxis, right? So what is Praxis? It's, if you hang out in the internet, you might hear this. If you hang out in the DSA, you might hear this. The whole idea is it's a process. It comes from the ancient Greek. It's a simple way to think about it is you do your research, and then you do an action, and then you reflect on the action, and that takes you back to research, and so on and so forth. And a lot of what I think we wind up doing day to day in observability and tracing is this process, this praxis of looking at our code, trying something new, reflecting on what we've now found, and then doing it all again, finding that next step. Because a lot of times this is what we have, right? We've got this horrible system of pipes and then little bright lights along the way, and maybe not all of those are equal. A lot of times we'll build systems that tends to treat all data that we're going to feed into it as completely equally important. We're going to treat in pretty much every tracing system, there's no way to say like, hey, this log might be important sometimes, but it also might not be important sometimes. We just say span.log or, event.add log, whatever. We're feeding a bunch of data in with the assumption that each of these points of light has a constant voltage and a constant importance to the overall view of our system. And a lot of times how this impacts us is oh my God, I have all these spans. What are they? I mean, this is what I asked. Like when I started getting it, this is like, what the hell's a span? We really, it's maybe a fault of this practice, the practice, I should say, not the praxis, but the practice of tracing is that we jump you with a bunch of like really technical academic terms from this, it's like, oh, just go read the specification or go read this paper from Google, right? And it's going to start saying like, oh, spans and traces and DAGs and da-da-da-da-da-da. And most of the time, when I talk to people and organizations that are just kind of starting out with LightStep or just in general, it's like, hey, tracing. And they say, well, what is all this? This doesn't, no. That's the general reaction. It's kind of like, this is a lot of work, right? This is a lot of extra stuff I have to do now to write an application that normally that no one told me how to do. I don't know what all this is. I know how to use Java. I know how to write C#. I know how to use these tools that I've been given. So we'll get questions like, how many, okay, sure, I know what span is now, but how many should I make? How do I know when I made too many? How much stuff should I put in each span? What should go in the spans? Gosh, why isn't there just a button I can push that does do all this for me? And very large organizations have done this. They've hired observability teams. Some of you might be a part of those. And that's the button you push if you have a lot of money. If you don't have a lot of money, then you're going to be stuck kind of answering these questions. And people say like, oh, well, you guys write monitoring software, so you probably know what you're doing, right? Well, yeah, kind of. We did learn, in the process of building LightStep, though, and as I've been a part of the company, I've seen like we do have a lot of practical applications of this. We've learned, okay, well, we make monitoring software, it should probably monitor itself, right? So in the process, you kind of get a crash course in, well, here's the right amount of monitoring, because we don't want to monitor so much that we bring down the application that's monitoring everyone else's applications. So this is kind of the what I call the 3 phases of learning OpenTracing or tracing in general. You start out and you get this tracing spec, and then you look at your code, and then you're like the lady in the meme, where you're just sitting there and it's like, okay, there's all this really highfalutin language, and then I learn all that, and I'm like, all right, great, I know what a span is. I've downloaded my my tracer, I've got Jaeger running, I've got this, I plug something in, I hit go, and then I go into Jaeger, or I go into LightStep, and I see like a hojillion things, because I just dropped in like, a Spring plugin or a C# plugin for ASP.NET. And now everything is instrumented, or like a Gorilla plugin in Golang, right? And so every single route, every single method, everything's decorated. Hurrah. Now I have all this data, I don't know what to do with it. So we start out, or how do I do all this? Da, 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 da. So let's wind it back. Let's say spans are about stories, and that's the big tonal shift of this presentation, right? So if you think, look at code, look at spans as parts of speech. You're filling in parts of speech. You've got your subjects, you've got your predicates, you've got objects, you've got modifiers. A span is going to tell someone, and it's always someone, right? Even if you're abstracting that someone behind 20 different layers of analysis engines and other teams and what have you, you're telling a person at the end of the day, here's what I thought this was important. Maybe you'll think it's important too. And here's the story of it. I start something, I modify that, in my first example here, right? I've got a span, I'm starting a trace. The subject of that is I'm withdrawing something from the system. I'm modifying it by saying, here's a context object, here's a scope object. These are important to understanding this line of code. What's the object that I'm working on? It's the request, and that's going to be persisted down through some nightmarish series of RPC calls or inter-process propagation. And then it's got a subject, which is withdrawal. Here's another example where my span is the subject, right? I'm adding fields, I'm logging stuff to it. None of these are going to go back and answer that initial question of like, well, how does a span know what's important? Because the only person that can tell you what's important is the person at the end of the line that's looking at the analysis, that's da-da-da-da, right? So what you have to do is you have to make spans that tell very rich stories. Spans that can build up these sentences that are going to have meaning to someone at the other end of the pipeline. So you've got spans now, and you have to start thinking about how do all these spans fit together, right? I've got scopes. So you think about kind of the breadth of your trace or your transaction that you're analyzing, and what we got here. So all right, we can think of a transaction as the entire trace. Most of the time, especially in kind of Dapper-based, modern web apps, you're thinking about, all right, someone on a client is clicking on a button, and that's going to go da-da-da-da-da-da, da-da-da-da-da-da, and return a response, and that's my transaction. Maybe the result of that was I modified a field in a database, or I've put work on a queue, or whatever. Although that's really, what else do we do but put things in databases or put works on queues, right? It's kind of, that's sad, isn't it? So that's your transaction. Now I'm going to go, let's say I've got microservices. I've got some sort of distributed computing thing going on, really cool and hip. So every time I'm hopping from process to process, most of the time that means I'm crossing a network boundary, right? Let's go down another layer. So maybe I'm going from library A to library B. I'm going from my API proxy layer to an actual concrete implementation, or I'm going from this thing to that. I'm going from ORM to something else, or I'm going from foo to bar to baz. I could be doing a lot of things in my actual code where I'm jumping between libraries that maybe I don't control, especially in the case of if you have an observability team, or if you're just using open source instrumentation, maybe someone's come and done the hard work for you. This is really common with like a database wrappers. So a good example in Java, you can download this thing, add it to your Maven, your POM. It says wrap every JDBC connection with OpenTracing. So now every time I make a database call, it's traced. Cool, right? And finally, I have function to function to function to function. And I think we all hopefully know what functions are. So how do we map that into spans? How do we figure out what the name of any of these things are? This is another finding from LightStep. Naming things is hard, right? There's a whole joke about this in computer science, but what you find is a transaction is too big, right? My transaction, the logical thing I'm doing here could be add friend, upload picture to thing, modify some relationship, right? Add a customer. There could be that add customer, that add friend could be an abstraction over 20 or 30 or 100 different services working in concert. Now, is it necessarily? Maybe not. But imagine if you add friend is actually kicking off all this other stuff, right? Like I add a friend, cool, but now there's like 40 other things that need to know that I've added that friend. So my simple span, my simple operation has grown to have this horrible long tail. We see this a lot internally with we do analysis. So like you add a span to some buffer. Well, that actually okay, so now you've added that span. Cool, simple, right? Except that now we have metrics processes that need to be aware of that and need to go in and do add counters, add gauges, do update statistics in maybe one or multiple databases. Generally, if you're thinking about my operation is kind of the logical thing that I'm doing, you're thinking too big because there's a lot more stuff going on in the long tail of that than you'd think. And it goes down from there. But if you start saying like, okay, fine, I won't do bigs. I won't name them after the operation. I'll name them after like do thing in operation is a little too small, because if you start instrumenting every function you have, now you have too many spans and you're overloading your system with tracing data. And a system that has too much data is, either you get into the sort of Sophie's choice, right? I have to put a lot of restrictions around how much data everyone can store because I'm storing petabytes of data. Or B, everything is too large and I'm missing interesting things because they're falling through the cracks because I'm not looking with a fine enough scope. So a good example, these are things I pulled from like our stuff, is good operation names, update project metrics. And this works in the sense of you can namespace these spans, right? So I can have update project metrics and I can namespace that with what actual service am I updating those metrics for? Is API key authorized? Again, it's a little bit bigger than a function. It's a little bit smaller than a library. It's not as big as a transaction because a lot of things are realistically going to call is API key authorized. I'm not going to have a separate is API key authorized thing for every single service I have. And assumedly, that's an important part of the workflow of my application. Another shout out here on database level, like that's when you're probably going to get into like, well, select is basically a function, but it's also logically it makes sense. What else are you going to call a select statement but a select statement, right? The only way we end up making sense of all of those different operation names is with namespacing. So I could have, again, I could have thousands of gets, I could have thousands of posts, I could have thousands of individual calls to is API key authorized, I could have a million calls to SQL/select. So how do I actually wind up figuring out what select that is? Well, there's some trade-offs here. At transaction level, at the entire transaction, I've got the trace ID, which doesn't give me a name that I can really associate with, which isn't great generally. At the process level, when I'm actually dipping into something, my tracer is generally going to give me a component name or a service tag. So that could be, client, server, be a custom tag I set. At the library level, I'm going to have a component tag. And then at a function level, all I'm really going to have is logs. I'm not going to have a lot of information to really distinguish between this SQL select and that SQL select, because the only sort of contextual information I have when I get down that far is what happened on this individual execution of this individual function. When we are thinking about how to namespace these spans, I find it helps to think about it, how, what do you actually have in the context of your single trace? So if we go back to my is API key authorized, well, how does that fit into everything else? If I'm searching for, I want to find out where the performance issues are and is API key authorized, I'm thinking, okay, so I start out, I have a GET request, that goes into a service, that checks to see if I'm authenticated, then maybe does it go back up or does it just go into, okay, now we're going to see if you're authorized. And then if it is, then I go back to the parent span and then more work happens. I go down again, I make some database calls, I come back up, traces over. Each of those actions that I described has kind of a separate and distinct logical child or logical reference. So either this action, this span depends on this span follows from this other span, right? When I'm doing analysis on these, it can be very helpful to say, to use both the kind of those middle two there, process and library level, or service and component tags, to do my sort of sorts and searches, because it's a lot easier to say, okay, for every, here's a query, an example query in your mind would be something like service name equals whatever, HTTP status code equals 500 or 4xx. So now every time it goes to this service, I want to see if there's a related piece of a related span that has a 400 or 500 error on it. And then I'm going to compare those to sets of histograms. Here's kind of an example, not really in any sort of format, but an example span that sort of combines some of these. So we've got our namespace is service component operation. We have tags like HTTP method, status code, error, a project ID, a region. We have timestamped events. So it started, we log happened in function A, log happened in function B, log an event, and then the span finishes. And with an analysis system, you're able to actually kind of take some of these really high cardinality things, right? Like those parameters on the logs, the project ID, imagine that wasn't project ID, but customer ID, and maybe I've got 1 billion customers. You can do interesting sort of pivots on this data and say, well, I want to see everyone that in project ID 123 with a customer ID of in this range that had this parameter or that parameter in the logs. Because with effective namespacing, at least, I can cut down the searchable space really, really rapidly. Which is a trick we do kind of with our internal stuff, or not internal stuff, but the external stuff. Like we effectively restrict the amount of, data that we have to comb through at any one time by providing these sort of pivots on, service or namespace, as it were, in order to reduce search space, which means we can store more data more cheaply and give you sort of a better recall of, hey, what's actually happened to this particular interesting query over time. So here's the promised lessons learned. We've actually implemented LightStep pretty thoroughly, to the point where you can debug LightStep using LightStep, which is what our, we've got good stories about SRE, internal SREs doing that. There's a really funny one where we were on a sales call. I was not in this call, but there was so this is a secondhand story, but we were on a sales call and something broke in the demo. Like, I don't remember exactly what, but there was an oopsie. And the guy who ran the demo switched over to the self-report project, which is each of our environments has kind of a self-reporting loop, especially the demo environments. So switches over, looks up the query he typed in as a log field or whatever, finds the error that he had just run into in sort of the immediate recall window, and was able to say like, oh, well, here's what happened, right? So it's obviously very valuable to have a monitoring software that's monitoring itself, even though it's kind of a chicken and egg thing, right? If the monitoring software is broke, can you trust that it's monitoring itself, right? Yeah. And another thing I would like to point out is that we still use a lot of time series metrics. Like, I think everyone does. I mean, there's some things that it's just like a count or a gauge is going to be super valuable for. So tracing can give you those time series metrics. Like, we can pull stuff out and put it in a Grafana from traces, but you're still, someone could say, oh, you only need traces. Well, maybe, but we still find value in, actual normal metrics platforms. That said, spans are more expensive than logs, right? I was talking to a guy that used to work for Heroku, and he was telling me about the kind of the issues they had trying to do distributed tracing back in the day. Their biggest thing was they were IO bound or on the network, because what's Heroku? What's a platform as a service? So they've got tons of stuff going over the wire. And whenever they tried to turn on any kind of distributed tracing, they would essentially blow out the EC2 network stack, and by putting so much stuff through, because there's so many different requests and they're multiplexing a lot of processes onto each host. So if they have 100 hosts, and there's maybe if they have 100 processes per host, and there's a, let's say, 10% tax, well, now you can only have 90 processes running. If you try to make 100, then now you have problems. Even if you're not instrumenting too much, like let's say you didn't have that particular problem, just like, well, we do any kind of tracing at all, even really lightweight tracing, we're overloading the available network bandwidth of our boxes. You can just, every single RPC call is instrumented, great. Now you might be throwing out thousands of spans per trace, which isn't going to be good for anyone. So you dial it back and you say, okay, well, we don't need all this stuff over here. We need this. If you start passing around too much baggage, spans are cheap, because a span ultimately is a trace ID and a span ID. It's two 128-bit fields that go across HTTP headers. And then you unwrap them and do whatever. But you start adding in all the cool stuff, right? Like, oh, I can pass in the customer ID. I can pass in the user age. I can pass in some tracking thing from some JavaScript library that is on the front end, and I can do all this stuff. And now I'm taking and tossing, instead of two 128-bit values, I'm putting, maybe 5, 10 kilobytes of stuff in every request from the client. And then every time I unwrap that baggage, or every time I unwrap that, span context, I have to pull all that baggage in, put it into a new span. Whenever I send that to another process, I have to pack it all back in, do it again, And that's where you start to see kind of the real performance hit of over instrumentation, in my opinion. It's not, oh, I just have too many spans that don't have a lot of information. It's that I'm putting in a lot of baggage and I'm just exploding the amount of data that it needs to make every single hop. Also, I haven't mentioned it, but sampling obviously also adds wrinkles to this. So that said, I spent a lot of time talking about like what's negative here. You know, everything's in trade-offs. You're gaining the reduced, you know, firefighting time, the ability to see these kind of performance insights that you get from tracing is going to outstrip the disadvantages of I'm adding a couple KB into every single network hop, right? Let's assume, you know, worst case, you're saying like, oh, it's a 20%, you know, off the top in terms of how many workloads I can run on a single host. Okay, well, you start 2 more computers for every 10. Does that cost money? Sure, but that's not my problem. That's the bean counter's problem, right? Kidding. But seriously, like, what is 2 more EC2 hosts compared to on-call time? Like, what is 2 hosts versus 3 a.m. pages? Like, human time is probably going to cost you more than like computer time. So that overhead is easily paid back in the reduced amount of time that you have to the fact that it takes less time to fix problems and the fact that it takes, you know, it's easier to find these sort of long tail performance issues way in advance. So finally, some practical advice on better spans. Generally, you are going to prefer kind of a coarse grain span, but you're going to want to put more data in it. Not necessarily baggage, but you do want to make sure that you've got good logs. You want to make sure that you're adding really intelligent tags, because the thing that traces can do that is really hard to do anywhere else is deal with high cardinality and deal with really kind of cool analysis stuff. So the more data you have, the better stories each span is going to tell, the more useful those spans will be and those traces will be. Keep your tags kind of clustered together really well, because some of this is just like, oh yeah, no duh, but minute differences can cause problems, especially if you are in sort of a, you know, big team where maybe team A and team B aren't necessarily on the same page. You know, even if you don't have an observability team, have some, you know, generally agreed upon observability principles, right? Have a semantic conventions document that everyone's on the same page of, so that there's only one error tag, right? And there's not a lowercase c and uppercase E error. When you have a stack trace, attach it to the span via the log. More data can't hurt. Finally, centralize the start finish, and I'd also add to this inject extract in framework code so that your application doesn't have to deal with scope management. Scope management is hard. If you want an example of that, just go look at literally any OpenTracing repo that has a scope manager and look at the GitHub issues and watch all the people argue. Scope management's a tricky problem to solve, and it's better for one team to kind of make the decisions about like, this is how a scope works, this is when it finishes, this is when it starts, than it is to try to have everyone making their own decisions about it.